Hello, Keith Trecker here at VintageMachinery.org. So this is going to be part two of a two-part series of making or doing some replacement parts and doing some repairs to a bearing assembly on the 1917 Vulcan Iron Works steam locomotive out here at the Georgia Museum of Agriculture. So these are the bearings for the connecting rods on the steam locomotive. It's a little small industrial engine made in 1917, narrow gauge, 36-inch rail spacing. But over the years, these we've had some issues, or we've recently had some issues, I guess, with these bearings getting loose, and when we tore into them. There's some wedges in here that basically adjust these brasses in and out. So on the crank pins on the wheels, and anyway, we got to make some new parts. And I've already in a previous video made some adjustment screws for these wedges. One of the wedges in here is stripped out, and so today's task is we're going to be making one of these new wedges. So let's zoom in here, and we'll talk about the project and get started on it. So again, here are the brasses that go over that little crank pin on the wheel, and this is again for the connecting rod. And over time, these brasses will wear, and they need to be tightened. And the way that is on the back of this brass. I don't know if you can see it, but this back surface in here is at a taper. It's at a 9-degree taper, and there's a wedge that has the same taper on it that fits up in here, and with a screw, you raise and lower this, and when you raise that taper up, it basically just scooches this bearing forward, and that's how you tighten it up when these brasses start wearing. And this wedge here, the hole through here that the screw goes in, it's stripped about halfway down, and it's slipping and getting loose on there, and it's just time for this to be replaced. I believe that this is an original part. I believe that this is an original part to the 1917 locomotive. It's got some, looks like part numbers stamped on it. Anyway, I can't assure that, but from what I can tell, it looks like it's original. But we're going to have to replace this, and to do that, I've got a block of steel here. This is the right thickness. The width is a little bit high. We'll have to mill that down, and anyway, we're going to have to basically carve that part out of this block of steel. That's going to be the task for the day. So we got some challenges here. You know, obviously just getting it to size is no big deal. We've got to get this taper on here and get that done accurately, which we'll do that on the milling machine. And then also, if you notice, we've got these radiuses on the back side, and that's because this piece fits in here, and you notice there's radiuses in the top and bottom, and when this raises and lowers, that's made so that it can go all the way to the bottom and all the way to the top. If that was a sharp corner, we would greatly limit the travel. So we got to put those radiuses back in there, and anyway, that's going to be a little bit of a challenge too, but anyway, we'll go work through the process, and let's get going. We'll start by taking this block of steel and cutting off a piece to that thickness, or length, I guess, actually, and we'll get started milling this out. So I've got my blank here that we're going to make that part out of, and just bandsaw this, a little bit oversized. So we're going to need to mill this side to the correct dimensions. Of course, we got about 1/4 inch we got to take off the top. And to do this milling, you know, sure, we could use the vertical mill with a fly cutter or a shell mill or whatever, but I've decided I'm going to go on the horizontal mill. I've got this little slab mill here, and anyway, I like using my horizontal mill. As I've said before, this is a fresh regrind. It's good and sharp. This thing is razor sharp, so it ought to do a good job of cutting this. I picked this cutter up somewhere in a bunch of horizontal mill cutters, and it was all dipped in the stuff where it had just been freshly reground. I pulled all that off, and you know, this thing is, like I said, razor sharp. So let me show you a little challenge though, and I've ran this before, and I'll show you our fix for it. So this is the arbor we're going to run on. This is a 1-inch arbor, horizontal milling arbor, and it has a 1/4 inch keyway in it. So for whatever reason, I've noticed that a bunch of my horizontal mill cutters, though, with a 1-inch slot, the keyway in here is not 1/4 of an inch, it's smaller. So, you know, this is measuring about 160 thousandths. So what I did at one point in time is I actually took a piece of 1/4 inch keyway and I milled it down so that it would have the right key on the top here. So it's kind of a little adapter, I guess you could say, to use these type cutters. Let's go ahead and put our cutter on. So I'm going to slide that right about there. This cutter's razor sharp, so I'm kind of gripping it with a rag here just to protect myself. And that fits right up over that little special keyway. And from there, we're just going to put some bushings on here. And that's probably far enough. We'll go ahead and put our bearing. This is where the outboard support will go to give me some support on here. And I want to keep this area in here, relatively small so that we can, the less area you got hanging out here, the more rigid your setup will be. And of course our setup here is a little bit longer there, so we'll go ahead and just add a few more bushings to the end and put our nut on. A shorter arbor would be fine here, but this is the arbor I have, so we're making do with what we got. And I'll wait and tighten that up after I put my support on. Next thing, I want to extend my overarm supports out. That's good. And get my this is the bracket that will actually fit on the overarm supports to hold that outboard bushing. And I usually like to just wipe these down. You get a little dust and trash in these, and I just want to clean it up before we put it all together. All right, go ahead and tighten this up. So before we pull the bushing up over the bearing, I'm going to squirt it down with a little oil, and then I'm just going to, using my rack and pinion here on the overarm support, I'll pull that over. Now, some people try to put this whole assembly on and just go over all three of them. I like to tighten it down over the overarm support and then pull it up on the bushing. It just seems like it goes on better. Trying to get all three of those things to line up sometimes can be difficult, but when you just pull it up on, everything just lines up magically, and it really works well. So we'll go ahead now and tighten up the overarm supports on the top of the mill and move on. I've got my big vise here that I use on the horizontal mill sometime, and mounted up. Got our plug in here that we're going to be milling, and basically I've got this rough cut on both sides here. I want to get that machine down, so I just took a square and squared up off of a fairly clean side in there. That should get me good enough for what I need. So we're going to mill off about 50 thousandths in this first pass. So we're going to come in here, we're going to touch off right there, dial up 50 thousandths, and get a good smooth face on this side. Then we'll flip it over and actually cut it to the proper width. All right, we're about ready to start cutting here. What I want to do is just come in here and touch off on this piece. We got our arbor running at about 93 RPMs, and I don't know how many cutters are on that, teeth are on that cutter, but it's a lot of cuts per minute. And I'm going to go ahead and just bring my table up until I touch off. Getting close. Getting real close. Alright, it touched right there. We'll zero this. I'm going to back the table out. And we're going to come up 50 thousandths. Right there. We use my cool mist on here to give me a little bit of coolant, and should be ready to start cutting. Got my feed set right now for 1 inch per minute. Don't like the sound of that. Let me see what we can figure out on that. All right, so we've slowed things way down here to get rid of that chatter. So I'm down to about 35 RPMs on the cutter, and we cut our feed rate down to about a ½ inch per minute, and that seems to sound pretty good. Let's see what we end up with when we get through with this. Let's show you what we got here. Obviously, when we first started to cut, we had a lot of chatter in there, and you can see that marks in there. When I slowed that cutter down, you know, that is nearly a mirror finish. I know you see those lines across there, but actually what you're seeing is the reflection of the cutters in here. It probably doesn't show up on camera as it does when I'm looking at it, but it's like a mirror finish. I ended up playing with my feeds, and I got my feed rate back up to 1 inch per minute. We're still cutting good. In fact, I can probably go a little bit faster than that. I think what I'm going to do is come back out, just take a few more thousandths off of this, just to get me a clean cut across there and get this chatter out of there. I took another 10 thousandths off that other side, got a nice finish. We just flipped it over, and I've got, this is probably 150 thousandths still to take off of this. It's hard to tell because this is still a rough edge on this side, but just measuring across. So we're going to take about 75 off of this pass and clean it up. We'll get a good measurement and then make a finished pass. So we need to get a good measurement here on how wide this is. We're shooting for 2 inches, 225 thousandths. So I'm just going to use a little depth micrometer, and I'll put it on the face of the side I just cut. We'll run this down. I've got a ground parallel in the bottom of my vise just to give me a good flat surface to work off of. And that looks like 2 inches, 326 27, 26, somewhere along there. So we've got, let's figure out what we got. So we need to come up 78 thousandths. I'm gonna release the vise. It's gonna drop down a little bit, but that's all right. So that's 75, 76. I'm having to, when I clamp my vise or clamp my table down, it pulls it up a little bit. So anyway, that's 78 thousandths. So that should be right on the money. We'll go ahead and make a finish pass on that. Went in and did that second cut off camera. So let's check our work here. So we're after 2-inch, 250. Well, there it goes. About a 1/2 thousandth over there. And about the same right there. That's plenty good enough. You know, it's really not that critical on the width of this, but that's well within tolerance regardless. So anyway, that's now the same width as this one. And the next step here is we need to cut the top off, and we're just going to use the same setup we got over there in the mill right now. Let's just see roughly. So we're looking at about a 1/2 inch we got to take off of there. So I'm set back up over here. This time I got the tall end sticking up, and we need to take a 1/2 inch off of that, 500 thousandths. I'm going to go ahead. The nice thing about these horizontal mills, you can take a really heavy cut with them with no problem at all. So I'm going to take half of that distance, 250 thousandths, 1/4 of an inch. So we're going to touch off on that surface, and then we will drop it down using the indicator and plow through it. Just raise this up again until it touches off. And we're touched right there. Zero my indicator, and we'll come up 250 thousandths. 100, 200, and 50. This is not a finished cut, so I'm not worried if it takes off a little bit more. We'll get a measurement on it and go from there. Let's let her rip. Well, I about messed up there. If I go from this side, it'll work, but I'll be climb milling, so the cutter will be trying to climb up onto the part, and I would rather, on this old mill, go the other way. There's advantages and disadvantages to climb milling. One of the disadvantages is if you got an old machine with slop in the table, you can wreck a cutter. So I'm gonna go back to the other side, and we're gonna set this back up again. That looks like it's touching there. Go ahead and pull the cutter all the way out now. And again, we'll go up 250 thousandths. $100, 250. All right, we should be ready to go now. All right, here we go. I decided to just flip it over. We still got a kind of a rough edge on this side. Figured might as well just go ahead and clean it up on all 4 sides. So I measured it and we got about 255 thousandths to go. I think what I'm gonna do is take a 200 thousandths cut, and that'll leave me about 50, 55 or so to make a cleanup pass, and that way I can get a good accurate measurement once I make my first cut and dial it in. So we'll go ahead and do this. I think you've seen enough of this milling. We'll just do this off camera and bring you back at the end. So the project's coming along nicely here. We've got our blank now cut to the dimensions in both the width and the height. Thickness we're just fine on the nominal size. So now we're ready to start getting into some of the more the other things we got to do. So there's 3 more things we got to do this. Number 1, drill and tap a 5/8 hole down through there, and that's probably the next thing we do. We'll go ahead and punch that in. We need to cut the radiuses on the 2 back sides and then cut the taper on the front side. So let's go over to the vertical mill. I need to figure out exactly where that hole is, and we will punch that through and go ahead and tap it while we're out there, 5/8 11. So I've got my block in the vise here on the vertical mill now, and first thing I need to do is I need to find my edges on this so that I can measure over. So I need to come in a 1/2 inch from the back. Center will be over 1 1/8 inches. So we're going to make basically this corner 0 0, and I use my edge finder to come in here, find these 2 edges, dial it in, put it 0 0 on my DRO, my digital readout, and then I can just dial right into where I want to go. So let's do it. All right, so with this edge finder, we're just going to come in and until that jumps over right there, and that should be 0. So, and I like to double check it a couple of times just to make sure I got it. I'm getting the same number and over again, and I am. This is a 1/2 inch in diameter, so off of that 0, I need to go in 250 thousandths. Well, a little lesson here, I guess. I got in here and was messing with this thing, and I could tell when I was reading on my digital readout that when it said it had moved 250 thousandths, it wasn't on the center of this edge finder, and I knew there was a problem. So I stopped and started doing some investigating. I actually got my dial indicator out and measured it. And you know, I was moving it 250 thousandths, but the digital readout was saying it was only like 180 thousandths, which is kind of concerning. So anyway, I went around here and pulled the little head off of the read head off of my magnetic scales on my DRO, and a little piece of trash, a little metal shaving had gotten back behind that thing, and it was giving me an erroneous measurement. So I cleaned everything up and again got out the digital, or got out my indicator and checked it, and it's dead nuts on right now. So anyway, just had to do a little troubleshooting there. I thought I would share that because yeah, sometimes you just need to clean these your read heads on your digital readout. So anyway, we're back good now. I've got that one edge. We'll go ahead and get the other one in here, and we should be ready to go. All right, let's do this the back side. Go ahead and drop that down. Come in here until that edge finder jumps over. Right there. 0. Double check it. Check it one more time, that's good. So now come back up on this one and go in 250 thousandths. Right there. And that one looks like it's on. So that should now have my back corner here 0 0, and I can just dial into my measurement on the digital readout. I got the DRO set on 00, and as you can see, this is right there in that corner, which is what we want to do. So I'm going to dial in 1/2 inch this way, and then 1 1/8 this way, and I've actually scribed a little mark on there to confirm them in the right place, and we should be right on it. I'll put you on the DRO so you can see it moving. All right, so we'll start by moving in 1/2 inch on our y-axis, so we'll go to 0.5 there. And lock my table down right there. All right, then we'll go 1 1/8, which would be 1.125. A little bit too far. Right there. And now let's take you back down to our part. And we got our center drill in there, and we're right over the mark. Let's go ahead and put a little dimple in there. And that's right on the money. All right, that's enough to get our drill bit started. So I'm going to start out with a 3/8 inch drill bit. We'll run that down through there, and then come back and finish it out with the correct size to tap that hole. All right, now we'll now drill this down to size, and again we're going to tap this 5/8 11. So this is a 17 30 seconds, 17 30 seconds drill bit, which should be right to put on a tap down through afterwards. So let's get it drilled out. So now we're ready to run a tap down through this. I've got my tap set up here with the tap follower still in line right where we drilled everything. So everything is lined up. So we should be able to just run this right on through there. This tap follower is spring loaded, so as I go down, I'll just kind of lower it down, and that'll keep everything lined up just like it's supposed to be. All right, I think I'm about through the bottom. It's a good thing I'm about out of tap. All right, let's roll it out.